All right, guys, so let's look at a couple more quick examples of ellipses. So example 5, this is one where we're kind of going backwards. We're given information and we want to try and put it together to form an equation. All right, so let's see what it tells us. So the first thing it says is we have an equation of an ellipse with its center at -3, 1. So I'm going to go ahead and just kind of sketch this out. So the center is at -3, 1. We have a vertex at -3, 3. So vertex at -3, 3. And then we have a focus at -3, 0. Focus at -3, 0. Okay. All right, so the first thing that I can tell here looking at this is that all of this information is oriented vertically, which means that our major axis is vertical in this case. Okay, so our major axis is vertical. Which means we're working with the equation x minus h quantity squared over b squared plus y minus k quantity squared over a squared is equal to 1. Okay, because the major axis is vertical, the a term has to be under the y. Okay, so now that just means that we need to figure out a, b, h, and k. All right, well, the h and k is easy. That's just from the center. So we know that the center of this is at -3, 1. So that's just our h and k. We also know that our from the vertices, we can find the a value. So remember, a is the distance from the center to the vertices. So in this case, that is just 2 units. So our a is 2. Okay. From the foci, we can find our c value because the distance from the center to the foci is our c, and that is 1. So c is equal to 1. So the only thing left to find is b, and for that we can use our formula b squared is equal to a squared minus c squared. So b squared is going to be equal to 4 minus 1, or b squared is equal to 3. Okay. All right, and I'm just going to leave it as b squared. There's really no point in solving for b itself because the equation has a b squared in it. So I'm just going to leave it right there. Okay. All right, so putting everything now into our formula, we're going to have, I'm just going to write it over here. Okay, so our center is at -3, 1. So it'll be an x plus 3 quantity squared. We said b squared is 3. Yeah, b squared is 3. And then plus our y coordinate of the center is 1. So it'll be a y minus 1 quantity squared over our a value is 2. So it's going to be over 4. And that is equal to 1. So that is going to be our final answer. All right, so the last example I want to look at is an application problem. So it says a bridge is to be built in the shape of a semi-elliptical arch. Okay, so let me make a sketch real quick here. So we have a bridge, something like that, okay, in the shape of a semi-elliptical arch. Okay, this is very crooked. Oops. Try to. Okay. All right, the span of the bridge is 100 feet. So the span would be this distance right here across the bottom. Okay, basically from vertex to vertex, and saying the distance is 100 feet. Okay. All right, and then it says at a distance of 40 feet from the center, the height of the arch is 10 feet. Okay, so let me go ahead and introduce a coordinate system in here. So just for the sake of simplicity, I'm going to go ahead and just say the center of our ellipse is going to be at the origin. Okay, so just for simplicity, I am putting the center at 0, 0. Okay, so then again, back to this. It says the height of the arch at a distance from 40 feet from the at a distance of 40 feet from the center is to be 10 feet. So basically what that's saying is here's our center. If we go 40 feet out from the center, then the height of the arch at that point is 10 feet off of the ground. So essentially this is just giving us a point on our ellipse at 40 and 10. So it's just giving us an ordered pair. Okay. All right, now the question is to find the height of the arch at its center. So the height of the arch at its center, we would be looking for this piece right here. We're looking for that distance from the center to the top of the arch. So if we're assuming that these guys to the left and the right are the vertices of our ellipse, okay, then this would be our major axis, and this would be our minor axis, which means that what we're really looking for is the b value. So this would be at a point 0b. If we can figure out what our b value is, then we can figure out what the height of our arch is. Okay. Now, a couple more things to point out here is if we know that the total span of this bridge is 100 feet, then from the center outwards is going to be 50 feet in either direction. So the coordinates of these vertices would be at -50, 0, and +50, 0. Okay. All right, so now if we're trying to figure out our b value, we're going to start by trying to figure out an equation for this ellipse. So the way that we've drawn it out here, we can see that the major axis is horizontal. Which means we're working with the equation x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. Okay. All right. For simplicity, we are just assuming that the center is at 0, 0, and that of course is our h and k. So we would have an x squared over a squared plus y squared over b squared is equal to 1. Okay. Also, in addition to that, because we know that our vertices are at -50, 0 and +50, 0, we can see that our a value is equal to 50. The distance from the center to the vertex is 50. So we can also go ahead and plug that in. And 50 squared is 2,500. So you have x squared over 2,500 plus y squared over b squared is equal to 1. Okay, so that's plugging in all of our pieces so far. So remember, our goal here is to figure out the height of our bridge, which means we're trying to solve for b. Okay, well, that is where this point comes in at 40, 10. So if we plug this in for our x and y, then we'll be able to solve for b. So if we plug that in, so 40 squared is 1,600 over 2,500 plus 10 squared is 100 over b squared is equal to 1. Okay, so now we're just trying to solve for b. So we're going to want to subtract the 1,600 over 2,500 over from the 1. So 1 minus 1,600 over 2,500 gives us 0.36. So 100 over b squared is equal to 0.36. So then we're going to want to multiply the b squared over and divide by the 0.36. 100 divided by 0.36 is, let's just do it as a fraction, 2500 over 9 is equal to b squared, and then go ahead and take a square root of both sides, and I'll change it back to a decimal, so 16.67 feet. So that is the height of our bridge at the center. Okay. All right, guys, so that is it for ellipses. So the next type of conic section we're going to look at is the hyperbola. So keep watching the next video for more on conics.